Cool. Can y'all hear me?
Yep.
Awesome. Well, thanks so much for having me. Really appreciate it. And it's gonna be fun if it's Earth observation is the theme. We'll start doing Earth observation from the ground, which will probably be the opposite of everybody else doing Earth observation from the sky or from space. And that's generally kind of the theme of what we've been trying to build with Pixel8 is crowdsourcing a 3D map of the world, but doing that primarily by bringing in a new vector to that map where, when we look at like Google Earth or Microsoft Virtual Earth back in the day, those were all built off aerial and satellite imagery or Vricon. And really what we've been doing with Pixel8 is seeing if we can also begin to bring in terrestrial imagery and take video that's in photos collected on the ground and turn those into 3D models and then align them to the more traditional aerial and satellite-based models, so we can kind of create this hybridized thing. But really facilitating that with crowdsourcing, like using open aerial LiDAR and open aerial data and fusing that with just videos that people contribute on the ground and see if we can use a crowd of people to build a really detailed 3D map of the world. And generally, one of the reasons that we dove into this was that as the world's kind of evolved from Google Street View style mapping of the ground, and folks started to want to use these things for augmented reality or autonomous robots and autonomous cars and autonomous delivery and things along those lines, or gaming simulation, dropping things into like Unity or Unreal. Trying to build a really large scale 3D map is super expensive, and folks like Google spend $500 million a year driving their vehicles and flying their planes and buying imagery and doing all these kind of things. And so accessibility for that is challenging, right? There's just a few people that kind of play in this space, like Amazon, Microsoft, Google, Facebook, increasingly some, next tier down like Niantic and Snap are beginning to play in this tier also, but it's mostly these massive multi-billion-dollar corporations that are doing it. Um, but all the cool things you could do with the data, we saw so many interesting applications, and seeing it kind of all bottled up kind of struck us the wrong way. And the team had actually been at Digital Globe over the last like 3 years or so, and we've been spending a lot of time working with satellite imagery. And again, access, we were trying to open up access to the imagery and getting people to do more machine learning. And against that imagery, we helped a lot with their open data program and making that more accessible out to folks. But still, just the gateway to getting the imagery is expensive. Satellites are expensive. Flying, launching things into place and flying planes is expensive. Driving, cars with sometimes $500,000 worth of sensory equipment on it is really expensive. So we really started thinking about, is there a cheaper way to do this that would really take advantage of a lot of the technology that was emerging that we were seeing that would really make this accessible to anybody, that anybody can begin to do, be their own remote sensing node to sense the planet and create 3D data from it. And so what we began to look at was seeing if we could leverage a lot of the open data that was out there with commodity data. So there's really great like open aerial data programs, whether it's like open aerial LiDAR in the US from things like USGS. They have a program called 3DEP. In the United Kingdom, they have one called DEFRA in the National LiDAR Survey. There's also aerial imagery programs like NAPE that are out there, plus all the remote sensing stuff with like synthetic aperture radar, with the Sentinel programs, the Landsat programs. And so many of these things have, phenomenal spatial accuracy, especially the aerial LiDAR, where it gets down to 10 centimeters. I was looking at data in London where it was like, the ground truth was like 3 and 4 centimeters off like an RTK measurement. So you get these, wonderfully highly specified, super accurate data sets. They're just not refreshed very often, right? Flying these things is really expensive. It's hard to do. And so they just don't happen very often. On the flip side, we have things like mobile phones and action cameras and vehicles with dash cams on them that are driving around all the time, and they're collecting data all the time. But the accuracy is GPS level. When you get into a city, that can be 10, 50, 100 meters off. And so it's not very good for building precise data sets. So the idea is really to fuse those two things together. Could we take the spatial precision of these open aerial data sets and fuse them with the really high temporal accuracy of these commodity data sets and get the best of both worlds, where we have something that's really highly spatially accurate and then is up to date and is perpetually being updated. So there's always new data being collected. And then could we compute that in a way that made it inexpensive enough to run at scale, so a crowd could contribute to it and we wouldn't bankrupt on server costs. So one big part of this that we haven't really talked about before is really building a ground control surface for what's going on. And so traditionally we think in surveying and aerial surveys, especially, that we have ground control points, or with satellites as well. And so you go and create these ground control points with a RTK GPS, and you have these little symbols that can get picked up in like drone or aerial photographs, and then we use those as control points. And then satellite companies have big networks of control points they use for doing orthorectification of their imagery. And we started to think about it a little bit differently. Instead of having a set of individual control points, could we create a ground control surface, starting with these open aerial data sets that have between 5, 10, 15 centimeter level precision, which was close enough for what we needed to do. We didn't necessarily need 1 or 2 centimeter on these individual things. And instead of having a few really precise points, have millions of pretty precise points. And then could we improve on that? Because one of the downsides of the aerial data is that it gets roofs really well, but it doesn't get facades very well. So if we could paint those facades with photogrammetry and use commodity videos and photos to paint them with more detail, then one, we have really cool 3D models, but two, we also have better ground control data. So once we've gone through and created all of those scenes of the facades and the details from a ground level, and we've co-registered those to the aerial data, now we have really good roofs and we have really good facades. And those facades may change, right? By time of the year, by weather, by foliage, by construction, things along those lines. And so if we're updating those things, we can perpetually improve our ground truth of what is the reality on the ground, what's the built environment, what does it look like? And that provides a trajectory to make all of our geospatial data potentially more accurate and more precise if we can continue to create these ground control surfaces that fuse the best of all the data we can find, and then all the additional data that gets added can use that as a reference to improve its own viability and spatial accuracy within it. The second part of what was challenging to make this all happen is that traditionally doing these kind of photogrammetric things are really expensive. Running doing a bundle adjustment for the entire globe was 200 years of CPU compute for Google to run it for Street View, to make a structure for motion point cloud, a sparse point cloud. Obviously, we don't have the resources of Google. We're like 5 people. So we needed to come up with a cheaper way to be able to compute these things. So one of the cool things we found with the ground control surface is that we didn't need to run the whole entire city or the whole entire globe in order to get everything bundle adjusted and projected into the right spatial coordinates. We could just take a small chunk. And so we would take a piece of video, take a 20-second chunk, make a point cloud from that, and then register it to the control surface. And then we do the next 20-second chunk, and the next 20-second chunk, and we put those together. And that's what you see here in the picture. Each one of those colors is a different colored chunk to run. And what we found was that when we did that, we could compute a kilometer of data with one of these really highly detailed 3D models for about $1.58 per kilometer, where Google, just to process the data off the Street View vehicle, is $250 per kilometer. That doesn't even get into doing the 3D aspects of it. And so the cool thing there is that it really allowed us to afford to be able to do crowdsourcing. That if it's only $1.58 to collect a kilometer of data, if it's messed up or it goes bad, it's not a big deal. And then that really allows us to open up the platform to get a lot more people contributing, because the costs of running that platform become much more feasible to do a global scale kind of project. And then the end result, right, is that we want to create a cool model for people. If you're asking people to go out and collect some video, you should give them something cool back. And so we've really focused on getting our photogrammetry pipeline to create a really cool high level of detail model that really captures the detail of your town, your neighborhood, your city, and allows you to do interesting things with it. And then add some features on top of that, like going through and semantically segmenting that data. So we can say what's building, what's ground, what are cars. Some of this for privacy reasons to get rid of cars and people. Other things just to be able to map certain assets like street furniture and curbs and lane markings and things along those lines that are interesting map artifacts. And then we began thinking about how to scale it up. So we had a group of people go and map downtown Boulder, where near where I live, and had everybody go out, and we made a little mobile app. People collected pictures. Later, we found that actually collecting like video off an action camera, like a GoPro or a GoPro 360, what took us an afternoon, I did in about 10 minutes on my bike. So we've been testing out different vectors for both collecting photos as well as collecting video and fusing those together to make these kind of 3D worlds, 3D environments with the data. And that's generally kind of how we've laid out the plan of doing a baseline mapping of an area when we don't have any data at all. First, going collecting it with video. Can we find existing video that's already out there? Can we get folks to go out with inexpensive action cameras to collect data? And then once we have that baseline, we can then take any photo with EXIF and GPS to update it or fill in the gaps and holes by co-registering that photo onto the 3D surface that we've built out. And so our first whack at this, which is kind of a brazen ripoff of CloudMade from back in the day, was to do an ambassador program. And similar kind of concept to what CloudMade did early on with OpenStreetMap of get people to go out and try to map their communities. Since we have the dependency, it's kind of similar, especially with early OSM. You went out when mapping parties with GPS units, or even tried mailing GPS units to folks. Similar thing here, like mailing a 360 GoPro camera out to folks. So we started this ambassador program. We started taking applications for it last week. If folks are interested, I'll put the form at the end, also tweet it out and reference GeoMob. But basically, we're going to mail 360 GoPro cameras out to about a dozen or so mappers in cities around the globe. And these are kind of applicants that we've had so far into the program. You see it's a little US heavy. It's actually a little Europe light, especially Southern and mid-Europe. And obviously South America and Oceania. We definitely need some love there also. But as a bastion of European folks, if there's interest, definitely let us know. We'd love to add some more folks in Europe collecting. Definitely more women. We've gotten really good diversity by geography, ethnicity, race. But for some reason, so far it's been super male heavy. So any women on the call that are interested, we'd love to get a little more variety in there as we push it out. And here's our first ambassador outside of our own engineering team in the US has been in London, and they've been out collecting Soho and City of London and kind of everything in between. So you can kind of see these are the what gets generated from the mappings once they push out. And then, since we are a business and we're trying to keep this all funded and working so that we can run the community, basically just to be really upfront with the business model for how we do it, that maps for humans are free, and for machines they're for free. So we charge the robots, the humans get the data for free. So basically you can download the LAS, the EPT, the PLY, the mesh of the data and do whatever you want to with it. It'll be an open license that's commercial with no hindrance on it. And then if you want to use it for augmented reality, autonomy, things like that, that's what we sell. And that's kind of how we keep things running. And then a big part of that obviously is keeping privacy going. And it's one of these really great situations where the business is optimized along with privacy, because really what we want to do is map the built environment. Things like people and cars make for bad data because they're transitory. So we're really looking for features that are fixed to help localize things or to make maps of a geography, and the buildings and people are fluid, so we really don't want them in the maps. The nice thing is photogrammetry kind of naturally removes that. You can see here where we've picked up the person and the cars. When we see the photogrammetric model, they actually get wiped out of that. And then we can also run semantic segmentation that you can see in the images. So the actual core photos have people and cars scrubbed out of them, so they never even get a cursor. So there's kind of two levels of removing anything that might be private or personal within the data. That's pretty much it. Hopefully I didn't run over the time. I meant to start my timer and then totally forgot when I was trying to get the screen up. But the URL for applying for the form for the ambassador thing is at the bottom I know that's a whole bunch of letters that are probably hard to write down, so I'll definitely tweet it out to GeoMob on after this. But any folks that are interested, we'd um, love to hear from you, and love to get more participation in Europe. And really excited just to see more geographies like we're seeing for London. I think one of the really fun things about this during the lockdown and the pandemic has been, we can't travel, we can't leave. And so being able to explore a city through somebody else's footage and 3D models has been really cool. To be able to walk through London and see some of those visuals has been really exciting. And hopefully seeing that in a bunch of places around the globe over the next couple of months will be a cool thing for folks to experience.
Very nice, Sean. Stephen, you gonna handle the questions? Wait, you're on mute, Stephen.
Yeah, the questions will be better if I can actually hear them, Sean. So in the product, how much of the data is actually crowdsourced and how much is bulk sourced, e.g. the LiDAR?
Mm-hmm. So all of the terrestrial data is crowdsourced currently. We have done some projects for customers where they'll basically pay us to go out and collect data for them because they want to test out the concept on a campus or a small geography, or begin to scale that out. And then the bulk is what we call the reference, and so that's the aerial LiDAR, for instance. And generally, we look for open data there. But we're looking to crowdsource that as well. We're actually, building out an interface where, you can have your own ground truth and upload your own ground truth. So if you have open aerial data available in your place, or you're doing drone photogrammetry and you've created some 3D models with traditional ground control points, and you want to use that as a ground reference, we're allowing people to upload their own reference. And then, it looks like something like this once you push that in. And then you can begin to paint that with your ground data.
Right.
So we'll be pushing in reference ourselves, but we don't want to limit folks on being able to go and build their own reference, build their own ground truth, and add it into the platform. So we'll be looking to crowdsource both sides of that equation. We'll obviously be helping everywhere that we can, but we don't want to limit folks if they're interested in building out some of that reference themselves.
And Mark asks whether the new iPhone 12's LiDAR capabilities are going to help with this initiative.
Yeah, 100%. I think, we're just strapped on the number of engineers to go and start experimenting with it. But certainly, an iPhone LiDAR app that allows you to go and scan areas and include those into these maps would be fabulous. One of the limitations is the LiDAR has a range of about 5 meters. So doing really broad scale mapping is tough, but I've seen a lot of really nice scans of the outside of houses and buildings and streets that work quite well. It's just kind of learning to operate within that 5 meter radius. But I think that's only going to improve, right? You think about what the iPhone camera looked like 3 or 4 years ago and how much it's improved. So I think the range on that LiDAR and its suitability for outdoors mostly been engineered for indoor so far, but I think it's only going to improve. And really, our thought is how can we stitch all this stuff together as handheld LiDAR sensors become more of a reality, as more photogrammetry happens, as more of this 3D capture happens, how can we take all of this and mesh it into one 3D world? And how do we make it open and participatory and done in a collaborative way? So I think, so much of what's happening in augmented reality and autonomy now are happening in these silos. And I think there's a lot of parallels to early OpenStreetMap, obviously, and that's where a lot of our motivation and homage comes from. But we really like to see the next evolution of that data hopefully be open also. And there's so many benefits of having an open ecosystem of data. And it's even kind of almost antithetical to the web in some ways, that these AR things are happening in very proprietary ways within. Interoperability isn't really something that's, there's folks like the OpenAR Cloud Consortium that are working on it. But it's kind of dwarfed by the amount of money going in from the really big players.
Yeah, and I don't know whether anybody saw, there was an article, I'll try and tweet a link to it, about Facebook's new AR initiative, where they're going to have employees and contractors wandering around with some kind of goggles that will be scanning and picking up in real time people and places and all sorts of data, and almost no consideration being given to the privacy issues that raises. One more question here from Alistair, which I think has some relevance with my babbling on about Facebook. Is Mapillary a competitor or a partner?
I really look at all of these things as being complementary in the grand scheme of things, and even, obviously folks have concerns about Facebook and rightfully so on various privacy issues, but they've also been huge contributors to OpenStreetMap. And so I think, being able to demonstrate that there is an open data opportunity, and that all of the players will be better off within an open data structure, and they'll always continue to do their proprietary bits and pieces. But I think showing that path forward is really positive. And I think, Mapillary being part of Facebook is a good indication that they see a future trajectory for open also. I think, and removing the commercial restriction on that Mapillary data is a great step. I wish they would also include the full resolution data, because the resolution that's actually offered isn't really good enough for doing photogrammetry to solve these problems. So the good data is kind of behind the firewall, right? And the so-so data is out in the public. But outside of little nits and picks along those lines, at the end of the day, it's going to be complementary to have multiple projects that can work together, that can be interoperable, that can help build this out, because it's a grant, and it's a big ask at the end of the day. Trying to map the entire world in 3D with this kind of level of detail that we're looking at, and add on top of that it needs to be perpetually updated to keep track of all of these things and what's happening on the ground. And I think we've only scratched the surface on what this data can be used for, right? You think of all the things that OSM data is used for today versus when OSM first started, what the use cases were, and it's just exploded in a million different directions. And I think the same potential's here, right? We think of augmented reality and some of these autonomy things, but I think there's so many different directions once the data becomes open and people see what you can do with it, and all the different perspectives and additional data that's embedded in there. There's just lots of opportunity, and more opportunity than any one company or any one project can take advantage of. So I think at the end of the day, it has to be a collaborative effort. And we've tried to really work hard to, from the beginning with the foundation of this, make it open and collaborative and make the data accessible, et cetera.